How'd you go with adding that ABC analysis to your embedded SAC stories? Good? Well, it's time to crank it up a notch and add an XYZ analysis to it. Welcome back to the channel. A couple of weeks ago, I posted about the ABC analysis and talked about how it could help you to identify what is important by evaluating and categorizing your products based on their sales volume into classes, namely Class A for high value items, B for medium value items, and C low value items, and how you could add such an analysis to your embedded SAC stories in SAP S/4HANA Cloud. Whilst it is a good starting point, you may quickly find that it is not enough to give you the full clarity you need to make the decisions you need, especially when applied to managing your inventory and trying to figure out which planning method suit your material inventory policies best. By that, I mean that the ABC analysis might help you to identify those items that contribute the most to your top line, but it fails to account for variability, for volatility, which, as we know, has been heightened more than ever in the last couple of years and still very much so applies today, leaving the world's supply chains in disarray. As you can see in this example, I have a couple of products. The one in blue shows a pretty stable demand pattern, so planning it or predicting its future demand will present a lower risk, thus requiring me to hold less stock of it. On the other hand, the product in orange is very volatile. It's showing peaks and troughs from one period to the next, meaning that I will need to carry more stock of it to mitigate the greater risk of me not being able to fulfill an incoming order for this product, and especially if it's a high value item sold by my customers. This is where the XYZ analysis comes into play, and it will help you to further classify your product according to their variability of demand or sales or planned consumption. In this recording, we will show you exactly that, how you can supplement your ABC analysis with an XYZ analysis again in your embedded SAC stories in SAP S/4HANA Cloud. The ABC and XYZ analysis combined will help you to further classify your products from one of 3 to one of 9 classes as shown in this 3x3 matrix, based on their value and volatility, thus helping you to determine a more appropriate and realistic material planning method for your products. In the top left, you'll find the items that are of high value, exhibiting a stable but predictable consumption, down to the bottom right, where those items will be of low value, exhibiting a very high volatility and presenting probably quite a few challenges to plan, but hopefully there will not be many products in that category. Today, however, we are going to jazz things up a little bit compared to last time, as we will start by creating a custom analytical query and use that to build our embedded SAC story. And there is where we will add the XYZ analysis. As usual, we are going to kick things off by looking at the theory, the task at hand before us, and then jump into the system to build it step by step. Before we dive into the system, let's look at the problem statement from a theoretical point of view so that we understand what data we will find that we can work with when we get to the system, and what data we will need to add to it to be able to reach today's desired endgame, which is to determine the XYZ code for each of the materials that we will be analyzing in our embedded SAC story. So here on the left hand side we have our data source, the transactional data that will be available in the S4 system, and this data that is created over time as transactions unfold through your business processes. In today's recording, we will once again be using a billing info cube, so sales that have actually been invoiced to customers as the basis for our data source. So we'll have a certain number of materials with a certain number of sales that have happened over the last 4 periods, as the system that we are going to be using is a fairly new system, so it has only been set up since the beginning of this year, so we only have really 4-month worth of data in there. So this will be the data that is available to us to work with. Now, what we are also going to do today that is going to be slightly different to what we had in the ABC analysis recording is that we are going to create our own custom analytical query that we will then be using in the Embedded SAC story. And you might be asking, but why do we create our own custom analytical query? Why can't we just not use a standard one like we did last time in the ABC analysis? Well, the answer is fairly simple in that there are certain functions that we need to access and leverage that are available in the custom analytical query tool, but not in the Embedded SAC story tool. To be more specific, what we need to be able to do is we need to be able to determine the variation coefficient. And really, that is what signals variability. And so this is going to be a calculated measure, so we'll need to add this to our custom analytical query. And the variation coefficient in itself is a very simple calculation in that all it is the, if we look at the formula here, it's the standard deviation divided by the mean of the values that were supplied for that material over the period of analysis. And we could absolutely have done this also in the Embedded SAC story. What we cannot do in the Embedded SAC story is derive the standard deviation as well as the mean. And we will then add these two in our custom analytical query, and those both will be, again, additional measures that we add, calculated measures that we add to our custom analytical query, but they will take the form of exception aggregation. So as I said, we need to derive those two values, then do this simple variation coefficient determination by taking the standard deviation, dividing it by the mean, and based on this variation coefficient and based on the threshold values that will have been indicated, we'll be able to determine the XYZ code. So here, for example, we have X as 5, but if we were to say that, let's say the Y items was anything less than, let's say, 60%, so all of a sudden you see that we have a few more Y items, and we'll amend the X items to be, let's say, less than 30%, so that we have a few X items showing up in the analysis as well. So obviously, once we have determined the XYZ code, combined with the ABC analysis that we performed last week, we will then be able to determine the ABC XYZ code for all of our material. So we'll not only have visibility of the value that they represent to us, but also a representation of their variability, and hence an indication of how difficult or easy it is going to be predict their demand patterns, and hence how much risk it is going to have on our inventory carrying policies. So now that we have looked at this from a theoretical point of view, let's just jump right into the system. So now that we are in the system, and as I intimated in the introduction, the first thing that we are going to do today is to create our own custom analytical query. We are going to use a SAP standard query as a starting point, and we will be using the same as the one that we used for the ABC analysis, which is C revenue from invoice query, and we'll use that as a starting point to copy and create our own custom analytical query. So I'm just going to call this PRE ABC XYZ data. So we'll keep it as it is. And once we are in our own custom analytical query, we'll give it a name. So I'm just going to say ABC XYZ analysis data source. Now, I'm not going to muck around with the field selection for the sake of expediting this particular recording, but you could obviously go through the field selection and select the field as per your own preferences. What I'm going to do is I'm going to go straight to display. And again, what I will do here is I'm going to get rid of all the fields just so that we can follow along more easily what we are going to be adding. compared to what the starting point was. But again, this is a personal choice. You could leave them in there if you were going to use the additional fields such as the quantity, the credits, and so on and so forth in the embedded SAC story as well, or even in the custom analytical query. Now, what I've done here is I have, based on the copied query, only kept the sales organization as a row, and I've kept the net value as a measure. The next thing that we want to do, because we'll need this as well, is we want to add the product, and we're going to add this on the row axis. So it's now going to show up with my sales organization. Okay, so at this point, what I can already do is I can save my draft. Right. And before we get into the nitty-gritty of the XYZ analysis, just to play catch-up, because remember that we want to do here is marry the ABC and the XYZ analysis in the one report. So the first thing that I need to do is to add the revenue contribution of each material so that we can again use that information to determine the ABC code of each item when we get to our ABC XYZ analysis in the embedded SAC story. So what I'm going to do here is I'm going to add a new calculated measure, and we're going to call this revenue contribution. And if you recall from the ABC analysis, the revenue contribution is going to represent the percentage that the net value of this material that we are going to be looking at in the analysis contributes to the overall revenue of all the materials. So this is also going to highlight a different way of calculating this in the analytical query, whereas last time what we did was we added this information in the embedded SAC story. So we've added the revenue contribution. We're not going to touch decimals and so on and so forth, but what we'll do is we'll go to the formula editor, and we are going to there add the formula that we are going to use to be able to determine this contribution. So it's going to be based on the net value amount in display currency, and that is going to then be divided by the total amount, which can be represented by a function that we have, which is called SUMCT. And again, it's going to be the net amount in display currency. So we are looking at the net value of that material divided by the overall value of all my materials, and we obviously then multiply that by 100 so that we have a percentage. So I'm just going to add a couple of parentheses so that we can then get our revenue contribution. I'm just going to say OK. So that has added the revenue contribution, and as I said, this is only allowing us to play catch-up so that we can have the ability to determine the ABC code in the embedded SAC story. Now this is where it gets interesting with regards to the XYZ analysis. Again, the first thing we're going to do is we are going to add a calculated measure, and this calculated measure is the one that will hold the standard deviation. So this is something that we need to calculate in the analytical query, and it's going to be an exception aggregation. I'm just going to put it in brackets EXC so that we can also then follow along as we go how that information was determined. So it's going to be an exception aggregation, and we'll just call this a standard deviation, we'll say. So we've got the standard deviation that has been added here as well as a calculated measure. We're not going to change any of the information that we have here. And what we do is we are going to go to the formula editor. And again, this is going to be calling the measure net value amount in display currency. But as I said, this is an exception aggregation. So we're going to activate the exception aggregation checkbox. And the function that we want to leverage here is not average, although we will get to that. In this case, it's going to be standard deviation. And the dimension that is going to be the basis for the exception aggregation is going to be the year month of creation. So let's try and find it by just typing creation, and we have here year month of creation. So essentially what this is saying here is it's saying that we want to calculate the standard deviation of the net value amount and net amount in display currency based on the year month of creation. So that's the standard deviation. The next thing that we want to do is we want to add another calculated measure, which this time is going to be the average, because if you recall, the coefficient of variation is the standard deviation divided by the mean, the average. So again, just so that we can follow along, I'm going to call this exception so that we know this is an exception aggregation, and I'm going to call this the average. And we have therefore the calculated measure that has been added. Once again, we are going to indicate the measure that this aggregation is going to refer to. So we go to the formula editor, and once again we indicate the net value, net amount in display currency, so that we know this is the information that we're going to be working with. Again, we say it's an exception aggregation. We keep the function of average, which is exactly the one that we want to be using. And once again, we are going to be using the dimension of year month of creation as the basis, year month of creation. Perfect. So we now have the deviation, the average, and the last thing that we need to add now is the coefficient of variation. So once again, we add another calculated measure, and this time we'll call this coefficient of variation. There we go. So now that we've added the coefficient of variation as an additional calculated measure, we are going to leverage the formula editor to indicate to the system what the expression should be. The first thing that we'll need to do is we're going to, in this case here, save the draft so that the previously created measures are available to me in that formula editor. Okay, so that has been saved. So we go to the formula editor for our coefficient of variation. And in the editor, we're going to find our calculated measures, which are down here. So it's the standard deviation, which is going to be divided by the other measure that we had, which is the average. And the last thing that we want to do here is go to the filters. And obviously, we need to also be able to use the year month of creation in our report to select the data that we would be wanting to work with. So we're going to say that it's going to be a user input value, will allow multiple selections, and we're going to once again save the draft and then publish the analytical query so that we can effectively use it in our embedded SAC story, which will be the next step. And before we do that, we'll just quickly do a data preview to make sure that we do have some data coming up for our custom analytical query. So I'm just going to indicate the currency of USD. Year month of creation I'm not going to enter. I'm going to use all the data available. And if we look at our data analysis, so again, let me just do a quick sort based on descending values so that we have from the highest net value down to the lowest. So here we can see the revenue contribution. So again, this is used for the ABC analysis. And this tells us that this amount represents 23.0174% of the total amount of $21,444.60 for the entirety of my data set. Then what else do we have? So we have the average. So 2468 is the average value across the period of analysis. We have the standard deviation, And we have also here the coefficient of variation, which, as I said, is really the end game, the value that we are going to be using in our XYZ analysis. Okay, very good. So we have data. So the next step is to go on to the embedded SAC story. So now that we have our custom analytical query defined, the next step is to go and create the embedded SAC story. And for that, we use the Manage KPI and Reports application. We go to the story section and directly click on create to create our story, and we're going to call this appropriately ABC XYZ Analysis. Oops, here we go. Next we click on configuration, and here the system will prompt us for the query to use as a data source for our ABC XYZ analysis. So we are going to indicate the custom query that we have just created and select it. And I'm going to add some default values. So we'll use USD as the currency. I'm going to use the sales organization where I have all of my data. And the first thing I'm going to do is remove one swim lane, so we've got a bit more real estate. I'm going to insert a data table. And we can already see that once the data is initialized, it's starting to appear in our data table. What I'm going to do is I'm going to uncheck the optimize presentation so that we have more data showing up on the screen. And just to again play catch up with the ABC analysis first, the first thing I'm going to do here is I'm going to add a sort on the net value by descending order so that we have the highest amount at the top going down to the lowest amount down at the bottom. For the purpose of adding the ABC code, we need to do a cumulative sum on the revenue contribution. So we're going to use the inbuilt functions of the embedded SAC story and add in a cumulative sum. So there we go, it has been added, and I'm just going to change the name, and we'll call this cumulative revenue. Now, to add the ABC code, which is going to be based on this cumulative revenue, I'm going to click on this column, add a column, and in this column we are going to call this ABC, and it's going to hold the ABC code of this material. And the way that we're going to determine that, so we're going to go to the function editor, and for this column we flip to the formula mode, and the formula is going to be just like in Excel, equal, and we're going to use the if function. So it's going to be if, open the parenthesis, and if you recall, the syntax of the if function is if the condition that needs to be tested, then we have comma, value if the evaluation is true, comma, the value if the evaluation is false. And for the ABC code, what we're going to check is the cumulative revenue. So we click on that column, and the first thing we want to do is we want to check and say, well, if the cumulative revenue is, let's say, based on the values we have, we're going to say, if it's less than 60%, then that material is going to be an A class item. So these are high value items. And then we are going to add another if condition to check if the value is not an A. So rather than just have a default value for the false, we add a new check condition. So it's going to be again if, open the parenthesis, we are still checking against the cumulative revenue, so we'll click on that to add it, and this time we're going to say that if it's greater than let's say 90%, then the value should be a C value, and anything else is therefore going to be a B value item. So let's hit enter, and we can see that we've got A's, we've got B's, and we've got C's following each other very nicely. Perfect. So that was just to play catch up on the ABC analysis that we had already covered last time, but we had to cover it again because we created our own custom analytical query this time. Now the next thing is the need to add the XYZ code, and we already have all of the information that is needed to add that determination. which is obviously the coefficient of variation, which is our coefficient of variability. So I'm going to add a column, and once again I'm going to be resorting to the formula editor and leveraging the if function to determine what that XYZ code should be. So I'm still in the formula editor. I flip to it for the selected column, and we're going to say, just like before, it's equal to if, open the parenthesis. And the if condition is going to be if the coefficient of variation is less than, so based on the values that we have, again, the coefficients I'm going to be using are not going to be very realistic at all. This is really just so that we have a bit of a spread of XYZ values. So I'm going to say that if the coefficient of variation is less than 0.1, that's going to give us X items, and the check for the false value will once again be an if function. Open the parenthesis. We are still going to be checking against the coefficient of variation, and this time we're going to say that if it's greater than let's say 60%, so 0.6, then the value, if true, of that is going to be the Z items, and anything in between 0.1, 0.6 is therefore going to be the Y items. So again, we add the false value as Y and we hit enter. And let's see, we've got a spread of Y, X, and Z values. There we go. So this has now helped us to determine the XYZ code for each of the materials that we have based on the coefficient of variability that we determined in our custom analytical query. Once again, as we did in the ABC analysis, you could add a threshold on the coefficient of variation if you wanted to have that color coding. And once again, we're just going to keep adding those three ranges, and we're going to say that we'll have one which is going to be X, we'll have the Ys, and then we'll have the reds to be the Zs. So once again, we're going to say that if 0 all the way to 0.1, just to match what we had in our XYZ, and here we're going to say that if it's greater than 0.6, this could really be infinity, so we're just going to say 999, and it's going to be less than 0.6. Let's click on apply, and boom, there we go. We've got our color coding that hopefully matches what we have for the XYZ determination, which looks to be correct. Yep, and also as you can see, because we changed the value or the name of the range, we can see here the range is called X, here it's called Y, and there we go. So then if we click on view, this is what the users will see when they get into the analysis. And there you go. So you now have the ABC and the XYZ code in your analysis. You can obviously get rid of all the columns that are superfluous, but you essentially now have some information at a more granular level than what we just had in the ABC analysis a couple of weeks ago. There you are. Hopefully this has given you some starting information on how you can further segment your products with more granularity by adding an ABC XYZ analysis to your embedded SAC stories, and in turn help you to decide the best and most appropriate method to plan your products. As usual, I hope this recording has been informative and you will find it useful in your adoption of SAP S/4HANA Cloud. We would really appreciate it if you would subscribe to the channel and spread the word to continue helping us provide free content. Until next time, stay safe.